So, um, this is lesson 3, properties of numbers. So one of the things that we need to be aware of is in this section, this can be very challenging because it is very abstract. It's not something that we use particularly too often. It is part of the number sense, things that you should know. You should absolutely know this. Don't misconstrue my you won't use it for not needing to know it. But it's sort of like a television. We take television for granted. We don't know how it transfers the picture from a building in Boston to California, or how it shoots up to a satellite and then down to your DirecTV dish and then converts it into pixels on your screen so it looks like a high definition picture of what is being photographed. So that's sort of the same thing here. We take certain things that we do in math for granted, yet we don't know why we're able to do that. So this section will deal with that. Here we go. So properties of numbers, you use the order of operations to simplify expressions. Good, right? We learned that the section before. Now we're going to recognize the properties of equality and identity properties. We're going to recognize the commutative and associative properties. We're going to learn a couple other mathematical rules. So why? Natalie lives 32 miles away from the mall. The distance from our house to the mall is the same as the distance from the mall to her house. This is an example of the reflexive property. So as I mentioned, we sort of take things for granted. We take for granted that Natalie's home, and then the mall. It'll be interesting to see if there's any malls around any longer. So the distance from Natalie, we'll call that d sub 1, the distance from Natalie's house to the mall is the same as the distance from the mall to Natalie's house. So that's d sub 2. And we know that d sub 1 will equal d sub 2. And what is the reasoning behind that? It's called the reflexive property. So we have a reasoning, we have a definition, we've got a term that helps us define that. Now, we just take it for granted. Yes, of course, the distance from Natalie's house to the mall is going to be the same as the mall back to Natalie's house. So much like television, much like a telephone, I have no idea how noise comes out of there, that little teeny speaker, to make it sound so real life. But there's actually reasons and very complex electronics that help us do it. So that's what we're going to be working on, the behind the scenes. So some of the vocabulary that we're going to use in this section: equivalent expressions, additive identity, multiplicative identity, that's a good word, multiplicative inverse, and reciprocal. That's just a couple. All right, so properties of equality and identity. The expression 4k plus 8k and 12k are called equivalent expressions. If we add 4k plus 8k, we know that that is going to equal 12k. So if we have 4 kernels plus 8 kernels in our pot, we know that we will end up with 12 kernels. I always try to associate variables with real world things so we can see that. So we've got these properties, and the first property that we're going to go over is called the reflexive property. Any quantity is equal to itself. For any number A is equal to A. Well, of course, Mr. Mac. Yeah, so 5 is equal to 5, 4 plus 7 is equal to 4 plus 7. And we call that the reflexive property. Symmetric property: if one quantity equals a second quantity, then the second quantity equals the first. For any numbers, A and B, if A equals B, well then B equals A. Again, this seems very logical, but mathematically they had to have properties to define that. So if 8 equals 2 plus 6, then the symmetric property says, hey, 2 plus 6 equals 8. The transitive property, love the transitive property. This one you will see and hear this, and this will be very important for geometry. Geometry will use a lot of these theorems and rules and properties and identities. So the transitive property says if one quantity equals a second quantity and the second quantity equals a third quantity, then the first quantity equals the third quantity. So for any numbers A, B, and C, if A equals B and B equals C, then A equals C. We will use that quite a bit in geometry. You will use that transitive property a lot when you write proofs and theorems. So if 6 plus 9 equals 3 plus 12 and 3 plus 12 equals 15, then 6 plus 9 equals 15. A famous one that I remember is if love is blind and Stevie Wonder is blind, then love is Stevie Wonder. And some people put God. If God is blind and Stevie Wonder is blind, no, if God's love is blind and Stevie Wonder is blind, then God's love is Stevie Wonder. Something of that nature. So you have love equals blind, Stevie Wonder equals blind, then love should equal Stevie Wonder. That's just a goofy one. Substitution, a quantity may be substituted for its equal in any expression. So we've been using the substitution property quite a bit up until this point. If A equals B, then A may be replaced by B in any expression. So if n equals 11, then when we see 4n, we can substitute 11 in for n, and we can do 4 times 11. Good. The additive identity. The sum of any number and 0 is equal to the number. Thus, 0 is called the additive identity. So if we add 0 to any number, we should still get that number. A plus 0 equals 0 plus A, which equals A. So 2 plus 0 equals 2, or 0 plus 2 equals 2, and that would be an example of the additive identity. What do you add to something to get itself? Well, you would add 0. The additive inverse. A number and its opposite are additive inverses of each other. So if I add the inverse of anything to itself, we're going to get 0. So if we add -3 to 3, we're going to get 0. If we add 4 to -4, we're going to get 0. So 3's inverse is -3, and -4's inverse is 4. So those are very important properties, additive properties. There are also special properties associated with multiplication. Remember, we really only focus on addition and multiplication because addition or subtraction can be written as addition and division can be written as multiplication. So we're constantly just focusing on addition and multiplication. There are also special properties associated with multiplication. Consider the following equations. The solution of the equation is 1, since the product of any number and 1 is equal to the number. 1 is called the multiplicative identity. So remember, what do we multiply to get that same number? Well, if we multiply by 1, we'll always get that same original number. So we see the similarities between the additive identity and the multiplicative identity. What do we add to get that same number? Identity, meaning the original. We add 0. What do we multiply? We multiply by 1. So the multiplicative identity says A times 1 equals A. The solution of the equation is 0. The product of any number and 0 is equal to 0. This is called the multiplicative property of 0. So remember how we had inverse to get 0. We would add the inverse of the original number to get 0. What do we multiply in order to get 0? What do we multiply the original number? Don't misinterpret reciprocals, because reciprocals aren't going to give us 0. So 6 times what would give me 0? Well, the only number that can go in would be 0. So a times 0 equals 0. So the multiplicative property of 0 and the additive inverse. So that's when we're dealing with zeros. Two numbers whose product is 1 are called multiplicative inverses or reciprocals. So yes, the inverse is going to deal with the reciprocals. So we say a times 1 over a equals 1. And this is the inverse in multiplication. And we have to do multiplicative inverse, much different than additive inverse. Or we know it as reciprocals. So reciprocals are really important. Any number times itself, any number times its reciprocal will equal 1. Any number times its reciprocal will always equal 1. So if we have 6 times the reciprocal of 6 is 1/6, that equals 1. If we have a fraction, 2/3, the reciprocal of 2/3 is 3/2 equals 1. If we have -3, the reciprocal is -1/3. That equals +1. So other multiplication properties, the multiplicative identity, we just saw that, a times 1 equals a. The multiplicative property of 0, a times 0 equals 0. And then the inverse, a over b times the reciprocal or multiplicative inverse, b over a equals 1. And those are examples. So let's look and see why or when we use these things. So it says evaluate the expression 7 times the quantity 4 minus 3 minus 1 plus 5 times 1/5. Name the property used in each step. So orders of operations, we would do this in orders of operations. So what would the first step be? Well, what do I have? Orders of operations. First one is always going to be grouping symbols. Do I have grouping symbols in the problem? Yeah, here are my grouping symbols. So I'm going to do what's inside this. So 4 minus 3. So if we do 4 minus 3, that gives me 1. And so going from this line to this line, what operation or what property, did I use? I used the substitution property. Instead of 4 minus 3, I used 1. I substituted a value in there. That's not what I want to do. How about there? Good. All right, the next step. So orders of operations. Do I have any more grouping symbols? Remember, this is not grouping symbols right now. That's showing multiplication. So we don't have any grouping symbols. Do we have any exponents? Nope. Do we have multiplication or division? Yep, we have multiplication. We have multiplication here, and we have multiplication here. Which one would we do first? The left one. We're going to do it left to right. So we do 7 times 1. 7 times 1 is the multiplicative identity, right? What do we multiply by 1 to get that same number? So we see in the description multiplicative identity. So we would use that property to move to the next line. Now, what would we do next? Now, we would do the other multiplication. And we see 5 times 1/5. That is the multiplicative inverse. Any number times its reciprocal will give us 1. So we know that the next line is going to be 7 minus 1 plus 1. And now, what are we going to do? Orders of operations. So we have 7 minus 1. Good. And we're going to do, actually, well, let's do this. We have subtraction and addition. So we do whatever comes first, left to right. So we'll do subtraction first. 7 minus 1 is 6. And what operation is that? Substitution. We substituted what 7 minus 1 equals to 6. And then we do 6 plus 1, which is 7. And that again is substitution. We're substituting 6 plus 1 to 7. Good? All right. So let's do a U-try. There are 2 problems here. Use order of operations to do the step and then tell me what property you used in order to do that step. So pause the video. When you're ready, you can unpause it and you can check your answers. All right, so in the first one, what's the first step that we're going to do? Well, let's look at orders of operations. Do we have grouping symbols? Yes. Okay. Inside those grouping symbols, what are our operations? We have multiplication and subtraction. What are we going to do first? Well, we're going to do multiplication. So 4 times 2. 4 times 2 equals 8. And what operation, what property did we use? We used the substitution property. We substituted 8 for the product of 4 and 2. Good. Now, do we still have any more grouping symbols? Yes. We still have grouping symbols that we have to use. We know that those are grouping symbols because there's an operation inside the parentheses. Now, let's simplify. 8 minus 8 equals 0. And what is that? What property is 8 minus 8? That's the additive inverse. We're adding the inverse of the original number. What's the inverse of 8? Negative 8. And we know that the additive inverse is always going to equal 0. Multiplicative inverse is always going to equal 1. Good. All right, now let's look at the next step. What are the operations that we have? We have multiplication and addition. What are we going to do first? We're going to do multiplication. 2 times 3. 2 times 3 is 6. So we substituted 6 for the 2 times 3. And then 6 plus 0 we're going to do, which equals 6. And that is the additive identity. What do we add to an original number to get that original number? We add 0. So that's the additive identity. Good. Let's look at 1b. Again, we're using order of operations. We have parentheses, so we have to do what's inside those parentheses first. Let's look at the operations. We have division and subtraction. What are we going to do first? We're going to do division before subtraction. 15 divided by 3 is 5, so that is substituting. Now we still have parentheses, and we're going to do our subtraction. 5 minus 5 is 0, and so 5 minus 5 is the additive inverse. Now let's look at orders of operations. We still have multiplication, addition, and multiplication. What one are we going to do first? We're going to do the multiplication before addition, and we're going to do the one on the left. So we're going to do 7 times 1/7. That is the reciprocal, so we know that is the multiplicative inverse in order to get 1. And now we have addition and multiplication, so we're going to do 6 times 0. 6 times 0 is the multiplicative property of 0. Any number times 0 is going to give you 0. And then we add 1 plus 0, which is the additive identity. Anything plus 0 will give you that original one. Some of you maybe wrote substitution. 1 plus 0 equals 1. Be careful, that's a unique step. All right, the commutative and associative properties. Nikki walks 2 blocks to her friend's Sierra's house. Hey, we have a Sierra. Do we have a Sierra? We have a Sienna. They walk another 4 blocks to school. At the end of the day, Nikki and Sierra walk back to Sierra's house, and then Nikki walks home. And then, sorry, lost my train of thought right there. The distance from Nikki's house is 2 plus 4, right? 2 blocks, and then another 4 blocks. And the distance from school to Nikki's house is the 4 blocks and then 2 blocks. So the commutative property tells us, commutative property of addition tells us that, hey, it doesn't matter if we add 2 plus 4 or 4 plus 2, that those are going to be the same. And I always teach the commutative property, the 2 M's, remind me of the word mirror. Because if we mirror 2 plus 4, what would we get? 4 plus 2. And to get it, oh, didn't mean to do that. To show it in an even, oh, that was weird. Stop it. To show it even bigger, if we have 4 plus 5 plus 3 plus 6, what would we want to add first? Well, looking at this list of numbers, I'd want to add 4 and 6 together. So we can commute that. We can push that 6 over there, and we can add 4 plus 6 first instead of adding 4 plus 5, because orders of operations would tell me to add 4 plus 5. Right? That's the first one left to right. But the commutative property, as long as all of these are addition, we are able to commute this. It's only when they all are the same operation. If we had multiplication in there, if we had something that looked like 4 times, or 4 plus 5 times 3 plus 6, we cannot, actually you could, but let's do this. I boo-booed. Let's do this. We cannot commute the 4 plus 6. No. And we can't do that because they're not all the same. So they have to be all the same. It has to be all addition for us to be able to use the commutative property. And this is a commutative property of addition. There is going to be a commutative property of multiplication also. Delete that. Did we go into? No. Well, let's show multiplication. It's interesting why they don't do that. I'm sure that there's a reason. So the commutative property of multiplication is going to be 6 times 3 times 5. So we can commute these two and make 6 times 5 times 3 to get 30, and then 30 times 3 I know is 90. So if I did 6 times 3, that's 18. 18 times 5, I wouldn't necessarily know that off the top of my head. So we can commute that, and this is the commutative property of multiplication. Okay? So you have commutative property of addition and commutative property of addition. And notice that I mirrored these. Instead of it saying 3 times 5, I mirrored it and did 5 times 3. The associative property, the 2 S's in associative, remind me to shift. And we're going to shift the parentheses. So if we shift the parentheses, we see that we have A plus B plus C. Well, that can equal A plus the quantity B plus C. So they're saying, again, it's sort of dealing with orders of operations. If we have 3 plus 5, well, let's do 3 plus 6 plus 4. Orders of operation tells me to do these first, but hey, I'd much rather add 6 and 4. I'd rather add these two because that equals 10, and that's a little bit more friendly as my first step. So the associative tells me to shift those parentheses as long as it's addition across all of them, It only works if you have addition for all of your steps. And then you see that we have the associative property of multiplication. So we would shift as long as all of these are multiplication. So if you have multiplication across, you can also shift your, so if I have a problem like 6.2 times 5 times 2, well, let's even put parentheses in there. Let's say it does that, right? Orders of operation tells me I would have to do that. But the commutative or the associative property tells me, hey, I can shift that and I can multiply 5 times 2 first instead. And that's so much easier to multiply by 10. I can do that in my head, or mental math, shall we say, opposed to multiplying 6.2 times 5. I don't know what that is off the top of my head. And then double it. All right, let's look at the real world example. Tell me that doesn't look like Miss Reeser. Is that Miss Reeser? I forget what her new married name is, but it totally looked like. I didn't know she was a model. Real world example number 2, apply the properties of numbers. So we've got a party that we're planning. Eric makes a list of items that he needs to buy for a party and their costs. Find the total cost of these items. So he has balloons he has to buy for $9.75, decorations for $18.50. He has food that costs $53.25, and then he has beverages for $22.50. So if we want to find out what the total, we would add all of them together. Now, if I had to add these 4 numbers together, I don't know if I'd add these first 2 up, because that I can't really do in mental math. If I was going to choose 2 numbers to add together first, I would definitely add these 2 together, because I can see that 50 cents and 50 cents work nice. And I would also add these 2 together because I have 25 cents and 75 cents. So I'm able to, notice what I did the commutative property. The 2 M's remind me of mirror, so I mirrored those 2 in order to get them next to each other, the 9.75 and the 53.25. And now I'm going to use the associative property because I want to group these. I want to add these, and I'm going to shift that. I'm going to add this before I add the next one. And then I get $104 for my birthday. So you try it. Raphael is buying furnishings for his first apartment. He buys a couch for $450. He buys lamps for $55.50. He then buys a rug for $43.50. And he buys a table for $75. Find the total cost of these items. So pause the video, write that expression, give me a numeric expression for simplifying or evaluating the problem, and then tell me how you would attack that. When you're ready, hit the unpause button. All right, so I think that the easiest way to do this problem, right? First, whoops, sorry about that. Well, let's do this, and then move you up and extend the page, and now move you down. So we would add 450 plus 55.50 plus 43.50 and then 75. So the first thing I would want to do is I would want to put these next to each other. And what property allows me to do that? Since it's addition across all of them, I'm able to commute the 75 over and switch it with the other ones. And then I want to add these, I want to group these 2 and group these 2. So typically, right, a commutative property tells me, or the orders of operation tells me I would have to add that one first, and then we get 525 plus 5550 plus 4350, and orders of operation would tell me to add those 2 next. but I don't want to. I want to add these two. So that would be the associative. I'm shifting the parentheses. The parentheses naturally are right here because of orders of operation, but we're going to move those to here. So we shift them over. So that's the associative property. And then once we add these two values, we substitute them in. And once we add that, we substitute that in for that value. So the total cost is $624. So use multiplication properties. Evaluate 5 times 7 times 4 times 2 using the properties of numbers. Name the property used in each step. Okay, well, I don't necessarily want to multiply 5 times 7 first. I think I'd rather multiply 5 times 2. So if we move this 2 over, then we can multiply 5 times 2, and that's a little bit easier because that'll give us 10. That is the commutative property of multiplication. Excellent. And then I want to multiply these groups, and that is the associative property of multiplication. And then once I multiply 5 times 2, I'm going to substitute it with 10, and 7 times 4, I'm going to substitute it with 28, and then 10 times 28 gives me 280, and I'll substitute that. So again, try these two problems, pause the video, and show me how you would go about doing these problems. When you're ready, unpause the video. So we have the two problems. We have 2.9 times 4 times 10. I don't want to multiply 2.9 times 4. I'm going to mirror those. So instead of having 4 times 10, I'm going to write 10 times 4. And that's the commutative property of multiplication. And then, technically, this isn't the associative property because orders of operation tells me I would multiply left to right anyway. So I would do the 2.9. So I disagree with that. That is naturally what we're going to do. So we do 2.9 times 10 gives me 29. That is definitely the substitution. And then I would multiply 29 times 4, which gives me 116, which is absolutely the substitution, using substitution property. All right, we have 5/3 times 25 times 3 times 2. Well, I think I'd rather multiply 25 times 2 than 5 over 3. So I'm going to commute those two. So I'm technically going to commute the 25 and the 3. If I mirror that, that would give me 3 times 25. And then I like this because 3 is in the numerator, 3 is in the denominator. Those are going to cancel, which gives me 5. So I'm going to multiply these two first and then these two. And so 5/3 times 3 gives me 5. And 25 times 2 gives me 50. So that is the substitution property to put in there. And then 5 times 50 gives me 250. Also the substitution property. All right, so that is it. That was a pretty long one. Check out the Preparing for Assessments and the answers and the other check your understanding problems and practice problems. And I will get the answers on that, the answer key. Thanks. See you in extra help if you need it.